direction that goes to the given point and slope, you would be using your y minus y1 equals m times x minus x1. And we would put in the point and the slope, so y minus 8 equals 2 over 3 times x plus 18. And then distribute. What was 2/3 times 18?
12.
36 over 3, so 12. And then add 8. So y equals 2/3 x plus 20. 2/3 x plus 20. That's actually recording. 5. To graph this one, we had to solve this. Add 3x to both sides. And divide everything by 2. So then graphing this, we have a y-intercept at 6 and a positive 3 over 2 slope, but I can't go up 3, so down 3, left 2, as many times as
that works too.
Questions on that one?
No, you don't.
As I mentioned before we started linear regression, that this is really 2 short units combined into 1. So we're going to start on the direct variation portion of that today, see how much of that we can get done today. If we don't finish, we'll finish tomorrow, but also start inverse variation tomorrow. Oh, I meant to show you this in Desmos. This one, if I put in Desmos, it can just, you would be able to see the graph. I'll do it really fast. I'll also need to show this.
Can I go to the bathroom?
Yes. What was it? Equals what?
12. No. Yeah.
6.
No, 6.
It was 6 at the end? Okay.
Wait, no.
The problem, whatever the problem was.
It's like negative 3x plus 2y equals 12.
It was 12. Okay. So here I can see where my x and y intercepts are, and if I were to count the slope, it is the same, up 3 to the right 2. The other one, if you did your y equals mx plus b and added sliders, you know your b is 2/3. And it's going to the point, what was it, 18, negative 18. What was the point? 8. So to go through this point, I'd have to move this until it gets through that point. But this only goes to 10, so if I put in 20, it exactly goes through that. So the slider doesn't really work for that one, but if you put it in, it does go directly through that point with that slope. Really quickly, your Delta math that was due on Friday, we did not get to 50%. So no else today. But remember that you have 2 due on Wednesday, and I won't see you on Wednesday, but we'll talk more about that tomorrow. Right, so vocab. A direct variation is a specific relationship in which there is a constant ratio between all ordered pairs. Direct variation equations are written in the form y equals kx. To get the ratio that they're talking about, we would have to solve this equation for k. How would I do that? How would I get k by itself?
Minus x to both sides.
Not subtract x, but do something with x. Divide. So if we were dividing by x, we would be solving for k. So we need to remember these two formulas. Y equals kx, and k equals y over x. To find the constant k, which is sometimes called the constant of variation, the constant of proportionality, all means the same thing. We're going to use that formula and divide y by x. And if it's the same for all of them, then that is your constant. You can kind of think about this like slope, but it's k, not n. So if we were dividing these, 4 divided by 1, 8 divided by 2, 12 divided by 3, and 16 divided by 4. We divided those. What would we get? 4 for all of them. So since we get 4 for all of them, that means k equals 4. This is direct, so we would write the equation y equals 4x. Questions on that so far?
So what is that?
That is your direct variation equation.
Oh.
We're going to use that further in a bit. Now let's try and do the same thing but from a table. Divide your y's and x's to see if your constant is the same. Negative 8 over negative 12, negative 4 over negative 6, 0 over 0, 2 over 3. Make sure to put this in fraction form. What would those be? Leave it as a fraction. Negative 8 over negative 12 would be, leave it as a
3
fraction.
over 2 over 3.
2 over 3. Negative 4 over negative 6. Also 2 over 3. We're going to skip the 0 over 0 because that wouldn't be anything. And then the other 2 over 3. So right now it looks like we don't have the same k value for all of them. But if I was thinking about how would this look on a graph, if I were plotting these points from 0, 0 to 2, 3, I'm going up 2 to the right 3. And then each time I'm going up 2 to the right 3. So even though this doesn't divide to become 2/3, on a graph it would still look that way. But also, if this is like our slope-intercept form, what would our y-intercept be?
0.
0. So if you see 0, 0, that's okay. That's part of it. It has to go through 0, 0. So this is direct. So the equation would be y equals 2/3 x.
So that means there's like the y-intercept is 0.
So you need to be able to find the k value from ordered pairs or tables, but also identify equations. So if you look at an equation, does it look like your y equals kx that we've been writing?
Yeah.
Yes. So if this is direct, what would the k value be? 3.
Good job.
What about number 6?
K value.
It would be direct. The k value is negative 4 over 5. Would 7 be direct?
No.
No. Why?
Because it doesn't have the
Okay.
it's not the
It doesn't have the x. So this cannot be direct.
I was about to say that.
Number 8, we would have to solve first. Divide both sides by 2. Would that be direct?
Yeah.
Yes. What would the k value be?
5 over 2.
5 over 2. Would 9 be direct?
No.
Why not?
Because it have a y-intercept.
It has a different y-intercept. That's not 0. So if it doesn't go through 0, 0, if the y-intercept is not 0, it cannot be direct. Okay. What about 10?
Yeah.
Yes. What is the k value?
Negative 1.
Negative 1. For number 11, again, solve. But when I divide, what if I left this like this? Y equals x over 2. Is that direct?
No.
Can I rewrite it?
Yeah.
How? So is it direct?
Yeah.
Yes. It's direct in either format. So if you see something like this, you have to know it's direct because you can rewrite it. Okay. Most equations written like 12 will not be direct because it'll have a different y-intercept, but we can solve it just to make sure. You have y equals negative 2x plus 3. Is that direct? No. Has a different y-intercept. Okay. Would 13 be direct?
Yeah.
Yes. So let's see. We subtract 5x on both sides. We have y equals negative 5x. You can put the plus 0 or not. So yes, it would be direct, and your k value would be
Negative 5.
negative. Alright. Questions on how we determine if it's direct from the equation?
So like, if it's like these ones, right? How do you find out if they are not direct?
If they don't have the same k value. Alright, once you finish, go on to the next page. You also need to be able to determine if something is direct based on the graph. So if it has a k value that goes through all the points, that's constant at every single point, and it goes through the origin, it's direct. So would 14 be direct? Yes. What is a k value?
3 over 2.
3 over 2. Would 15 be direct?
No.
No, why not?
Because it doesn't have a...
It doesn't go through the origin. Would 16 be direct?
Yeah.
Yes. What's the k value?
1 over negative 3.
Negative 1/4. And then would 17 be direct? Yes. What is the k value there?
Origin.
Which simplifies to 1. So as long as you remember it has to go through the origin and the slope basically has to be the same between all the points, it's correct.
Yeah.
Questions on how we find that from a graph? Now, so that's part of it. You also need to be able to use your direct equations to solve. So we're going to be using our two equations that we talked about at the beginning. I'll rewrite them. Y equals kx and k equals y over x. So when you see this, whatever numbers that you have both of, so for whichever order pair you have both numbers, take those numbers and find k. K equals negative 4 over 2. So k would equal what? Negative 2. Then once you find your k value, you're going to use the other order pair in your y equals kx equation. So we don't know y, so that's going to stay the variable. We know our k value is now negative 2, and we know our x is negative 6. So then what is our y value?
12.
Positive 12.
Yeah.
So if you wanted to check yourself, you could take your new y value and x values that they gave you and divide them. And if you get the same k value as before, you know you did that right. If you don't, you know that's wrong. You don't have to do the check part, but it is helpful to double check yourself. Questions on that before we do score? Alyssa, do you have a question? Okay.
Oh, sorry.
So we solved for y that time. Let's do 19 to solve for x. Same process. Start finding k. So 16 divided by 4. So k is 4. Then we're going to start setting up the equation. Y equals kx. Our y value is 24. Our k value is 4. We don't know x, so it's going to say x. How would we solve for x?
Then we divide.
We divide. So that x equals,
No, yes.
if I wanted to check this, I would take 24 divided by 6, and it should get 4.
So, which one is
The x equals 6.
You're looking for x.
Correct.
You're still looking for. You're gonna look for x for the rest of your
Can
life.
you please let me think about it?
Questions on this? Now this next part is the same, it just has more words. So let's try 22. If y equals negative 18 when x equals 3, find x when y equals 30. So our first step would be to find k. How would we do that?
20.
Negative 18 over 3. So that our k value is negative 6. Then we have to set up the equation. What would that look like?
Yo, hey.
30 equals negative 6 x.
Then negative 6x.
And then divide both sides by negative 6.
Negative 6.
It would be negative, not 6, but 5. I'm not going to write the check up here, but if you wanted to do it, you could. 30 divided by negative 5 is negative 6, so that would work. Let's do another.
So wait, what are you trying to find in the Oh, the x.
So we found x, let's find a y. So let's do 24.
No, that's not all the time. Just today.
What's our first step?
10 over negative 4.
Yes. K equals 10 over negative 4. Simplify that. What would that be?
Negative 2.5.
Negative 5 over 2. Leave it as a fraction. And then find y when x equals 12. We have to set up that equation. What would that look like?
Is this, there's gonna be underscore.
Yes.
Times 12. There we go.
Multiply that. This is the last thing that's going in this one.
But when does this quarter end?
The 26th of January.
26.
Y equals
Wait, shut up.
it is negative. There we go.
I was gonna say that, you know. Like, I kinda.
So if I did negative 30 over 12, it should simplify to negative 5 halves.
What?
If I did negative 30 over 12, it should simplify to negative 5 halves.
Yeah.
Wait, so is it direct?
Yes.
But I have like a y value.
This is our y value. I'm not sure if that answered your question.
So wait, so doesn't the y value have to be 0?
So you're talking about the y-intercept.
Oh,
If I were to solve for the y-intercept, it would be 0. Okay. We're not going to do many problems on the next page, but I want to do at least one.
The the applications of
Yes,
direct
the
and inverse variation.
So there are word problems that go with the direct variation. But what's nice about the word problems is how we just solve for missing values, you do the exact same thing here.
Oh.
There's just more words. So you guys don't have this part, but you do have this part. So when you think about direct variation, if it were to ask you, most of them will say, but if it were to ask you, is this direct or inverse? As one variable goes up, the other variable goes up. So the more you study, the better your grade. But these can also go down together. The less you study, the worse your grade. So these can either go up or down together. So let's read through the first one, and then I think that's all we'll have time for today. So the sales at a baseball game vary directly with the number of people attending. If the sales for a game are $12,000 when 800 people attend, determine how many people attend if the sales for a game are $15,000. What do you think is important? The $12,000, the 800 people, the $15,000. Right? You'll see the word vary directly or varies directly or directly proportional somewhere. Before those words, whatever comes before those words, that's going to be your Y. Whatever comes after, that's going to be your X. So then you can label all the other ones that match. Every time you see sales, that's going to be Y. Every time you see number of people, that's going to be X. What are we looking for in this problem?
People.
How many people?
How many people attend? So are we looking for X or for Y? X. So that's the biggest thing with these, knowing which one you're solving for. So once you know which one you're solving for, then you can start to solve. Just like what we were just doing, where you have both an X and a Y, use that to find K. So K equals 12,000 over 800. But in this, because it's real life, we want to put the units, so $12,000, 800 people. What would that be? 15, and with our units, that would be $15 per person. So that's our K value. Then we have to find X. So we're going to use our Y and our K in our new equation. Y is 15,000 equals, our K value is 15. We don't know X. Divide by 15. So that X equals 1,000 what? Dollars. Oh, not dollars.
People.
The check method still works here, so if I did 15,000 divided by 1,000, I get 15. So the process is the same. Do you have any questions on how we solve the word problem? We're going to do 2 more of these tomorrow and then start the inverse. But you guys can put your calculators away.